the cloud. Ooh, ominous. All right. Oops, let's go back. Okay, so as I was saying about grades. 10 points for attendance, automatically, you get it. No big deal. The lab assignments we're going to do in class, 45% of your grade. There could be up to 15 lab assignments. There probably will be a lot less. You might not finish them in class, so they are your responsibility after class to get done and submit on Blackboard. The quizzes, most of you should have already taken it before class. If you didn't, no big deal. I left a little bit extra time in Blackboard, so it's not going to like turn off on you. Get it done. Like, I think I put it to 13 at midnight, just in case, because there still are 5 students who I have not seen. So we'll see what happens. And then 18% is going to be either a project or a take-home final. I think a lot of you want to do an open book take-home final. Totally cool. Optional, you can do a project or an interpretive dance. Love to see an interpretive dance on GIS. That'd be so cool. I mean, if you wanted to do a project where you go out and you map the trees on campus and then take us a tour of them, that would be cool too. I love interactive things. All right. So any questions on me, class, stuff? Okay. Well, you can always email me with any questions, no matter how crazy it is. I actually had a student call me Sunday afternoon just to chat. I think she's lonely being in isolation. So that's fun. Okay. So what is geospatial technology? My notes are on several. Because I don't like standing in front of the podium. Give me a moment to. Yeah. All right, so first hurdle is often explaining what geospatial technology is. Well, it's good reading, so you should have a little bit of an idea. So who can tell me what geospatial technology is? It's like the trick. Hide your eyes. All right. So it's more than just like states and capitals. It's more than your favorite pizza place or where a tornado is going to hit next. It's all of these things. Ready? Who has hands up when you see one of these things that you've used? Yeah. Google Maps. Yeah. MapQuest. Oh, you're showing your age. GPS in your cars. Yeah, I have one too. You can stop raising your hands now because it goes into things like Tinder and stuff. But these are all other applications that are geospatial technology. Tinder has location-based services. So it's a database with your picture and a little bit of info about yourself, but also your location, because it matches you with singles that are nearby. Waze, another one of those mapping ones for directions. Airbnb, similarly, a picture of a location, all of its information plus its space. Because if you want a vacation in northern Vermont, you need to know the location of these things. And so when you think of things like Google Map and Waze and MapQuest, we used to call them GPS. GPS is actually the satellites for America up surrounding the Earth. These are, your car or your phone has a receiver that then uses mapping capabilities for directions. Zillow is another one, that's for house sales. And it also includes things like how good schools are, how walkability the neighborhood is. That's a spatial analysis using the terrain, which is pretty cool. Looped, which I have no idea what that is. Pokemon Go. Yeah, all right, cool. Not the only one. All of these are popular location-based apps. Face recognition will work. Okay, so all of you have used at least one of these items before. So you've used geospatial technology. Smiling and you can't see. I feel sad now. Here we go, right? So what is geospatial technology? This thing is in the way. How do I move it? Put it over there. Well, not too bad. Okay. So geospatial technology uses GIS, GPS, remote sensing, cartography, spatial analysis, and location-based services. Geospatial technology is all around us. It's on phones, it's in our cars, it's on the news, it's in the movies, it's in our video games, and it's become mostly ordinary. You'll notice, you'll also, that's not me. You'll notice, I think it's Google Maps, and then so they have the locations, and then all of the underlying non-spatial data that gets put into the map so that you can know more information, hours of things, stuff like that. Some of those previous applications that I showed on the slide might seem a little foreign to you, but you actually know more about this technology than you think you do. In the news, who can think of a recent news story where they showed satellite photography of something like fires in California, right? Or Australia fires, if you want to go back to last summer. This stuff is so ubiquitous to our life. It's like ingrained now. So even in video games, you've got the virtual reality. Mario Kart uses topography. There's a whole list. It's become basically ordinary. And that's a good thing, because now everybody's using it, and it's this emerging field. And when you get emerging fields, you start earning a lot of money. So, what are your questions about what geospatial technology is? Okay, we'll keep going. Let's talk about some real world applications. So it's being used in so many different fields. Chapter 1 has some examples. We're going to watch a couple of short video clips about some of these careers. Wow.
A Bastina surgiu em 1966. A Selby tinha acabado de se instalar na Figueira da Foz. A Bastina surgiu como um dos grupos que iria fornecer essa nova fábrica. Com o passar do tempo, os fornecimentos alargaram-se. Atualmente, a Bastina é um dos grandes fornecedores de Portugal, principalmente dos
So he's talking about a wood supplier.
Mais recentemente, é
Pellets, biomass, wood sawmills.
Biomass e também de algumas instalações de madeira. Em 2002, a Bastina envergou pelos caminhos da certificação florestal, começaram portanto pelas propriedades dos sócios da Bastina e dos fornecedores da Bastina que entraram nessa certificação e criámos o Grupo de Gestão Florestal da Bastina, que foi certificado em 2009.
A Bastina, ou o Grupo de Gestão Florestal da Bastina, tem mais de 1000 proprietários. Isso reflete-se em cerca de 5.000 propriedades espalhadas por mais de 100 conselhos. E como imaginam, gerir toda essa informação.
So they have to figure out how to manage the information for 5,000 companies.
Desde a caracterização da marca, a
Properties.
legislação, o plano de gestão,
These are all the properties.
toda a informação relevante, quer seja climática, quer seja edáfica, Gerir tudo isso sem um
So they have a
suporte
GIS
geográfico.
system that has
Então, usar a
climate,
informação existente
property
nova,
lines, all sorts of information that they need.
e toda a informação de gestão da informação digital.
You can access it in the
localizar
field.
as propriedades, caracterizar as propriedades, definir plano de intervenção e acompanhar a gestão ao longo do tempo.
And they can see the flat past and they can predict things in the future.
Nós vamos ter tecnologia acessível. Para começar, tínhamos que centralizar no escritório. Se alguém quisesse saber algo sobre as nossas propriedades, se alguém quisesse saber algo sobre a utilização das nossas propriedades, tinha que ir ao nosso escritório. Antes de termos o ciclo, os mapas estavam no papel e tudo o que fazíamos, desde os relatórios, desde a caracterização, era feito em papel. Hoje, o técnico vai para o campo, faz o levantamento de propriedade num tablet ou num telefone, consulta o levantamento feito por outro técnico e sabe se aquele levantamento não é repetido, se está bem ou mal feito, ao mesmo tempo que o técnico está a fazer o levantamento no terreno, a equipa do escritório está a ter acesso a esse levantamento. É permitido cruzar o levantamento que vou fazer com toda a informação digital existente, desde a parte climática, desde a parte gráfica, desde a rede hidrográfica, tudo isso é cruzado instantaneamente e em tempo real. Quem está no escritório acompanha o levantamento que vou fazer e pode orientá-lo. E mais tarde, quando quiser voltar à propriedade, não precisa ir com papel nem com mapas, usa a aplicação.
Onde a base de informação muito grande e essas ferramentas facilitam bastante quando põe à disposição, de uma maneira rápida e prática, as informações que são recolhidas, são trabalhadas. O acesso que se tem remotamente a essas informações ajuda muito, quando estamos numa área, poder aceder e ter as informações desse local, isso tudo ajuda bastante nessa.
E o mais importante é que ele vai conhecer a nossa forma de trabalhar e adaptou a tecnologia que tem às nossas necessidades.
All right. So, what are your questions about using GIS for forestry? You like dive super deep into that process, but the main point of this was that they were able to use tablets to go out and do surveys about temperature precipitation, rivers, roads. They can send that back to the office in real time. Satellite connection. So people in the office can make management decisions. So the forestry aspect of this is not something that's happening in Massachusetts right now. Like, there's a little bit, but not like wide scale. Wide scale, we're doing this right now in things like power lines, telephone poles. Actually, my town just had a company out. We paid them so much money. They made so much money off of my town because they got to go map every single telephone pole. It's insane. I'm like, hey, I can do this. I know how to do this. But they were out there with their little tablets, putting every single telephone pole location there so that our town knows how far apart poles are, which poles have like electrical transformers and other things. So then they can make decisions about where to put new ones, which ones are old and failing, etc. It's sad. I wanted that job. This one is about the Audubon Society. Ooh. Let's try that again. There we go. Audubon Society does a lot of environmental conservation.
Before the ArcGIS platform, our state conservation and bird experts, along with our national science experts, were all working off of disconnected databases. Being able to share data lets them collaborate, lets them come up with much more robust, larger conservation visions. It's completely transformed how we think about conservation and where we target our work.
We have volunteers collaborating with staff in a new way, collaborating with partners in a new way, using our GIS as a big spatial platform for collaboration.
The Sagebrush Songbird Survey is a partnership between Audubon, Washington, and the Department of Fish and Wildlife, in which we use the ArcGIS platform to a 7 Eastern Washington chapters to gather data on shrub steppe songbird species in such a rigorous manner that citizen science data is actually used by agencies.
Audubon showed up supporting this GIS platform. See, all of a sudden, we're using the tools to actually figure out the sites and not navigate to them ourselves. The scale of collaboration is just way beyond anything I had imagined.
Citizen science, I'm convinced, is going to play a bigger part in how we manage our resources, collect information, manage the resources in the future. One of the great things about this project with Audubon is that they are taking on the role of monitoring their citizen scientists. And this project that we developed really allows the Department of Fish and Wildlife to provide guidance to the state organization, and the state organization to provide guidance to the chapter.
A group of us actually got together at our house. We got several laptops on the dining room table, and we had a representative from S3 and coach us about how to navigate through ArcGIS online. Then we went out in the field and began to survey all of the dozen sites that are scattered around our county.
This ArcGIS platform has really enabled a grassroots effort to connect with state and national offices in a way that this work that has such meaning to all of us is able to grow organically into something that has become really powerful and regional and meaningful to all of us.
Really excited about what we've done as an organization, what GIS is doing for the conservation community, but also for the nonprofit community. The technology is so accessible, everyone accepts and is excited that GIS is in their toolbox.
Having the ArcGIS platform be part of Audubon's DNA has helped us produce better science. It's helped us produce better plans. That in turn has helped us do more effective fundraising. It has increased our credibility with our partners. And most of all, it fulfills Audubon's core mission. It lets our local chapters be authentic, credible voices in their communities for birds and for people.
Cool. So Esri is the maker of ArcGIS, which we'll use. ArcGIS Online, which we're also going to try to use. Plus a host of suite of tools that work like on tablets and cell phones to integrate with those platforms. Who can tell me what the Audubon is using GIS for? Bird migration, yeah. Anybody else? So if you can think of a conservation focus, they're doing it. The bird atlas is a huge one, which is amazing. They're tracking hawk migrations every year. They're kind of not this year, but there's a group that goes up to the top of Mount Monadnock and they count how many predator birds they see, and they put that into the GIS. The state of Massachusetts actually is doing a turkey count right now, so you can see turkeys around. You can take the GPS coordinates and put it into their system. There's a whole bunch of different conservation goals. How many of you like to go hiking? A couple of you? Okay, cool. So when you are on hiking, you start finding species around here. Keep an eye out for them because Mass DEP or Fish and Wildlife, they're always looking for that information. They actually just found a endangered orchid that nobody's seen in the past 20 years. It's this really cool orange one. I'll bring a picture on Thursday. All right, one more application, healthcare. I know at least one of you is interested in healthcare.
Inland Empire Health Plan is is a not-for-profit public health plan serving over 900,000 citizens of Riverside and San Bernardino counties who are low-income on government health programs. The official mission statement of IEHP is to organize and improve the delivery of quality, accessible, and wellness-based healthcare services to our community. For our over 900,000 children, families, seniors, and individuals with disabilities, we need to make sure they get the care they need. There's a lot of different challenges, and one is the geography again of that part. It's so huge, and being able to really make sure we've got the physicians and hospitals to care for our members across that huge geography. The other is healthcare is changing so rapidly.
In 6 months, we've gone from 650,000 enrollees to over 900,000 enrollees. So our challenge is continuing to make sure they have access to quality healthcare services.
We've had geographic information systems for a while, but now with Esri, we're really taking it to a new level. We need to know where our members are. We need to know where our doctors are. We've got to really hone in on a geographic level so we can do targeted interventions. We can look at particular areas to really focus our efforts.
We're able to present health information. We can profile our members, our providers, using all this rich data that we have available, but now we look at it visually through a geographic perspective.
We've met with key stakeholders in provider services, member services, our member group to see what we're supposed to really see using GIS. So we've come up with about 20 things that we think if we were able to see the visualization that would be helpful.
So these, get rid of that. These are a whole bunch of different things you could do for GIS and healthcare. Find places where healthcare isn't available that analyze gaps in care. You can actually take the points of existing doctors, nurses, clinics, and then extrapolate out. And green will be places where there's high amounts of care, all the way to red, and that would be places where they would need to put more healthcare. You can see how members are utilizing the care. You can provide routes for things like Meals on Wheels or the MART van that picks up elderly people and brings them to doctor appointments. You can see where bus lines overlap with healthcare providers. There's all sorts of things you can do.
We'll be able to serve our membership better by identifying where the needs are needed for things quickly in an effective analytical manner.
We're going to have over 1 million members by the end of 2014, early 2015, and our need to really focus our efforts geographically, both in terms of our members, where are our diabetics, where our diabetics are getting the services they need, and where are our providers to be able to care for those members. We need that geographic information system partnership with Esri to make it work.
So obviously these videos focused a little bit on Esri. That's because it is the biggest and most popular provider. We are going to look at some other programs that also do the same thing, like QGIS, all the same exact functions as the Esri products like ArcMap, but free. So we will get exposure to both of those. What are your questions about how GIS helps different professions? About, can you name a way that you can use GIS in your future? Do you have one?
Tracking the land.
Tracking land, yep. You can even set up an alert when cheap land becomes available. When trees are removed, yep. Remote sensing is great for that. You can have a satellite image of what the tree cover looks like now, and if it changes, you can be alerted that it's changing, so you can go out and it's not clear and it could be a lot. Because actually Greg Asner has a great TED Talk about that. I'll link it on Blackboard. He's awesome. All right, so now let's talk about the difference between geospatial and non-spatial data. So I know that was one of the questions from the reading. And specific things to say about that. So you can see how the stuff on the left is spatial data and the stuff on the right is non-spatial data. So spatial data is tied to real world locations. The parcel boundaries of someone's house or the shape and length of a driveway are all examples of spatial data. Non-spatial data is the stuff in the table. So student names, the value of your house, anything that's listed in the spreadsheet. Even if it's an address in the spreadsheet, until we match those numbers and letters to a real world location, it's still going to be non-spatial data. So let's do an activity. Do I have enough whiteboard markers for everybody? I might. 1, 2, 3, 4, 5, 6, 7, 8. Close. I have to disinfect the chair. Whiteboard marker. We'll make 2 lists. One of non-spatial and one of spatial, and you can add your ideas. All right, yeah, let's do 4 this time. That works. I won't tell you which side to choose. Go ahead. Right, if you haven't gone up, go ahead. Don't want to take a turn. Oh, I just put it for now. All right, cool. So, yes and no. So, states to visit as long as it's just the name and not like the coordinates. Yeah. Perfect. Google Maps, Google Earth, and Apple Maps are all software that you can view the spatial data, which is awesome. So it's all GIS software. Houses, school locations, lat long, so house, location are all spatial. Really, if you have location in the name, that's kind of like your trigger word. Location means it's spatial data. Good job. Awesome. So one more time, non-spatial is things that end up in a table. Names, values, numbers, stuff that doesn't have a GPS coordinate, lat long, easting, westing is different type of coordinate. Specific, like square in space, like a lot of parcel data. So we will get into this more, but spatial data has three types: point, line, and polygon. So houses could be a point or a polygon. You could have it like this on a map, or you could have it a whole house. Both of those are spatial. School locations, similarly, point or square. Lat long is the actual coordinates. If you think of roads, roads are a line, or rivers are a line. So you can have point, line, or polygon. And we will definitely go over that more in the future. But if you hear anybody say point, line, or polygon, that's going to be spatial data. All right. What are your questions? So the example I like to give is your tree species is non-spatial. Your location of the tree is the spatial data. Your height of the tree, non-spatial. Your coordinates of it, spatial. So you get to see a pattern there. Okay, let's talk about some online resources used for geospatial technology. Where did my phone go? I want to make sure there wasn't specific points that I wanted to make. Because if you think it's everything for you, oh boy. Okay, so now may be an appropriate time to discuss how so much of the world of geospatial technologies is available literally at your fingertips through mobile apps. For example, there is the Esri Map Book, which you can access digitally or on a computer, and it has all these different maps in it. And honestly, I would love to go through each and every one of these because I'm such a nerd and I love it. But I'm not going to today, just for time. I know you guys want to get started on the lab. You don't want to sit here and listen to me talk about traffic flow maps and how we can improve traffic flow for another half an hour. But if you're interested in any of these or more, because there's so many more, you can Google the Esri Map Book. There are things like first three are tourism. So you can make video game maps using GIS. You can come up with a good walk for tourists. London, New York City. Actually, one of my friends is doing one of these historic trails in New York City. So she takes old images of buildings, and they have kiosks now all over the city where you can look at the old building right in front of the new building, and you can read information about it. Plus, it's linked to an online map with a walking tour, all sorts of stuff. really cool use. Let's see. Oh, the next one's really good too. So, World Heritage Sites. This is so cool. This is a geography treasure hunt. Let's do this together. Let me grab you the link. I'll do this one together. Here, this is the link up at the top, treasurehunts.storymaps.esri.com/heritage sites. I know, right? This one's fun. Oh, is it hard to see? I don't know if I can zoom in on that. I can put it here. Make it big. Paste. There. What's that? Look at how big that is now. You can like not see it because the thing's over it. I guess that needs to kind of be there. All right. When you get to that website, you will see this full map, and you click on begin, and it'll give you a hint. So the first hint, that's picturesque ruins, and it wants you to pan and zoom to where you think the location is. Also, if any of you are ever want to become teachers, this is a good way to integrate GIS and a history or geography lesson, which I think is like 6th grade or 7th grade actually, 7th grade history. Similarly, there's ones about Shakespeare's literature, which is really cool. So you can adapt it to English. Give you a hint. The first one is Angkor Wat. It's right at the top. Somewhere past it. That's right. Oh, I remember that. If you don't know where Angkor Wat is, you certainly can Google it and then go to that location on the map. I can specifically. So zoom in. So it's somewhere. What does it say? That's okay. Doesn't it say something else? Hint. Once the capital city is Khmer Empire. Oh, I don't know where that is. I might Google where Angkor Wat is. No. Oh, you found it. Look at that. I know it's somewhere. Oh, I think it's in Thailand. Found it. Look at that. it's actually in Cambodia. Doesn't even want us to run. Oh, that's not that far away. Let's see. Cambodia is here. Zoom in. I don't remember exactly where. Guitar. Yes. Hmm? Yeah. What's the next one? Oh, you're going. Ah, that is hands, I think. That's say Michael's chapel. You can look at handy too. Look at handy gives you more information. There you go. Look at that. Maybe it did. I wonder what's there. Yes. Yay! You get a cool board when you're done too. It's a certificate and it says you're geographically literate. Yes, that's true.
Somewhere.
I'm not, no. So far away. Oh, Normandy. So try to find for a while. I know it looks like a square from here. Northwestern Cambodia. All right, so we still stuck on Angkor Wat, the first one. If you go to Cambodia, and in the northwest corner, zoom in a little bit, and you will see a location called Angkor.
Yeah,
Oh, you did already. Oh. All right. Wait. Or Cambodia. Northwest. Oh, I know, right? What is that line? That is St. Paul's Cathedral. Rasmussen. David the Great. Catherine the Great. Russia. What is this? Off-red animal species are endemic to islands. Galapagos? Yeah, where's that go? Oh, right here. It's right off. Actually, there it is. 3 hours. Galapagos Island is home to unique turtle species and finches that have cool beaks. All right. So, hope you guys continue to play with that. So, the imagery on those maps is collected by satellites and aircraft. While no map is completely unbiased, that one provides pretty much little interpretation or no interpretation. So you get to explore it a lot. You get to explore. It actually almost has you guys play where in the world is Carmen San Diego. That's actually my idea at the beginning of class. And that game is linked in Blackboard if you want to play it. So maps do more than just show where things are. They spark curiosity, they prompt further questions, such as what's nearby, why does it look like that, and has it always been that way? Maps don't only provide a picture, they also, I wanted to undo that thing. Can be interactive repositories of data. So this one is Earthquake Watch, which is a really cool dashboard. And this is a screenshot of it from last week. If you were to go to it this week, it would look a little different. So let's see. Last week, it had 100 earthquakes listed. This week, let's go to it and see. You can see that the latest earthquake was off of Mina, Nevada. It was a 4.7 ago. I'm pretty sure that these are all collected by the USGS. Yep. So people are feeling a lot of earthquakes right now in that region. Holy moly. All this morning, 8:53 a.m. So a couple minutes ago. Whereas when I screenshotted this, it didn't even tell me. I think that's Guam, actually, that it has listed. It's either Hawaii or Guam. So these dashboards like that, they can show you live data. There's some for crime reports. Every time there's a hurricane, I help map hurricane damage. So we go on Twitter, we find pictures that are geotags of floods or people needing help, and then we put it onto a mapping dashboard so that first responders can know where people need help, which is really cool. You can also have other types of data visualizations. If you see on the bottom, that's a time scale. Right now, I think it's dates and magnitude. So you can see how many big and small earthquakes are happening over time. It also gives you location, obviously. That's why we're here. The magnitudes, etc. And they're interactive. So you can click on the points of the map, like I was just doing, and it lets you see the information attached. And you can filter it to answer your unique questions. Maps also tell stories. So there's a story map about the refugee crisis in Somalia. So they also help you interpret the data. You can see, if you're on the site and you scroll down, actually, I scrolled to the correct place when I did the screenshot. There's a map, and it shows 6.7 million people in Somalia that were in need of assistance. And you can zoom in on that point, and it will show you specific locations for people that said they're in need. So to make good decisions about where to send a right cross, for example, you need good data. It has to be presented in a way that makes sense. And maps are a great way to do that. They don't just convey information and knowledge, they can also trigger emotional responses. This story map is about the opioid epidemic. More than 100 people die every day from opioid drug overdoses. So this map serves as a memorial to those who have died. Each point on the map, which then have been aggregated into bigger blobs, was added by someone who wanted to honor someone they lost. So it's not just something a map isn't just something to read or consume. So we can contribute and add to them. We can engage with our communities. We can use maps to share our own stories and to connect with one another. Maps can also provide innovative solutions. We can use them for problem solving. So this map was created with the goal of identifying areas where students might be at risk while walking or biking to school. So they took a whole bunch of schools and places where accidents have occurred and analyzed where students might be at risk. Then they put crossing guards there, more crosswalks, speed bumps. They can make those decisions about how to improve pedestrian safety. I'm just going to skip that part. Let's see, geolocation. I think we pretty much go over this. Yeah. So geolocation is like when you have apps on a smartphone. Have you ever been asked to share your location? I got asked this morning. I downloaded a hiking app. Do you want to share your location? Yes, of course. I need to know where you're hiking. Not only is it things that have maps, it's maps. Twitter uses your location or Facebook does too. So when you send a tweet or send an update, your location services on, that information can be mapped. So for example, this is a screenshot I took last week from 1milliontweetmap.com, which shows you texts in real time. When I took this screenshot, it was nighttime where we were, but it shows you where all the texts are coming from. People are texting from the middle of the South Atlantic Ocean. Probably is. There's some researchers down there right now doing seal research, so possibly them. Jack Harding's down there taking pictures. 29 people from Greenland texted while I was looking at this map, and that's one of the small circles. Isn't that crazy? Yep. So each second, about 15 new tweets are added. And if you wanted to go to hold on, let me see the website again. 1milliontweetmap.com. So geolocation, everything nowadays is tagged. You upload your photo. That's how I do the hurricane photos. When you upload your photo, it is tagged with the location. So not only is it good for hurricanes, but for tracking students at parties. Turn your phone off at a party. All right, so crowdsourcing in citizen science. We've talked a little bit about that, citizens as sensors. This one is an example of a story map from Esri's user conference, where you can take a selfie and then post it and their location to a map. That's simple usage. This was the hurricane example I gave. This was from 2019. You can see Hurricane Dorian. There was 829 photos that we mapped to show the damage. So when there were people on these islands who needed fresh water, I just take the photo and put it on the map. Somebody else goes out there and decides, hey, you need to bring the supplies to these people. You can help too. We might do that later in the semester. Like when we get to chapter 15, if we get to chapter 15. So a lot of you answered on that crowdsourcing question on the quiz. You answered OpenStreetMap. That's totally acceptable, and I'm going to go in and fix anybody who didn't get points for it. The answer they were looking for is Globe, which is a NASA application that uses crowdsourcing, but OpenStreetMap also uses citizen science to map things. I've mapped refugees. I've mapped some areas that are flood prone, where we don't know where the houses are until somebody goes out and maps them. And then there are people on the ground who can double check that you actually mapped them the right way, because sometimes you can't tell. All right, so let's talk about Google Earth, and this is the lab. If you want to, we have about 10 minutes. I don't know if we're going to get through the whole lab, but we can try. So, bring up the lab on Blackboard. Blackboard, you to lab 1. And it's going to tell you to open Google Earth. Right? And I know you already all know how to zoom in and out because you were just doing it on the World Heritage thing. You know how to move around. Who knows how to use Street View? You can drag the little guy, drop it. Yeah, a lot of people do. All right, cool. See, the advantage of teaching this class to a younger crowd is that you already know how to navigate most of these things, which is so nice. So, yeah, all right, I'll leave this somewhere out. You can start in the lab. There are questions to ask, and that's what we'll do on Thursday. I'll let you answer all of the questions, but just to get started, yeah. Open or play around. Make sure you know how to zoom in and zoom out. If you do not know how to use Street View, I can actually maybe try to show you. Let's see. Ooh, of course, it's not just like, let's explore Google Earth. Google Earth. Google.com/Earth. Launch. And it's taking a while. Well, when you get to the Google Earth site, you can feel free to zoom in and zoom out and look at the Street View. That's the thing I'm going to show you. Okay, here we go. I am going to go to, I don't know, let's go to Sheepshead Peninsula. This is where, I doubt there's Street View actually, now that I say that. View for Home of Ireland. That's weird. But okay. So what I did was I took this little guy, this little guy right here on the corner, and that's how you get into Street View. You drag and drop him where you want to be. So I just stuck myself looking at Bantry Bay in Ireland, which is where my great-grandparents are from. Holy moly, that's beautiful. Sometimes, if you end up in the middle of Boston, you start to see 3D buildings.
Oh, it was the school.
Yeah?
Yeah.
Awesome.
I don't know why. I was like, I didn't know what else to look at.
Yeah, no, that's awesome. So if you scroll to Pittsburgh University, it is 3D. Whoa, that is awesome. That is really cool. So we'll talk more about how to create 3D maps too, but they use a process called LiDAR, which I mentioned. They shoot lasers from a plane, and when it bounces back, you get a return signal, and you can test height that way. Hey! Is it really? Whoa! Let me think where that place is for something. Cool. There are probably other things that are 3D. I bet you the Eiffel Tower is. Maybe like Vegas might be 3D. Look at that. Just run around campus. I always like to try and find where my car's parked. Like, where was I the day they took this image? Whoa, the Eiffel Tower looks really cool 3D. It's so big. Holy moly. Let's see. Let's see where I can go. Come on, cross the channel. No. Okay. You can also see the bathymetry. You can see where underwater there's trenches. Let's see, France, Paris. I bet you the pyramids in Egypt are probably pretty cool too. Where is the Eiffel Tower on this map? Over there, maybe? Nope. That is sprawling urban park with trails and a zoo. But if I it's also hella slow. So I don't know where in Paris the Eiffel Tower is off the top of my head, but somebody else found it and it was awesome. I know, I don't have the keyboard. The keyboard's tucked away. For the rest of you, you can totally search it. Look at that. They've done a lot with the 3D since I've last played with this.
I know, they updated it a lot. It looks so much cooler. People put their actions there.
That is incredible. I mean, like, it's only been a month since I guess I haven't really explored it longer. Wow. What I like to do with the fifth graders is I have them measure their school, because there's, well, I have them on Google Maps to measure it. There's a measuring tool on here. Right now. But I have them measure their school and then measure the pyramids in Egypt. And they're always like, whoa. Or they go find their house and they're like, this is so cool, I've never seen my house, where's that light photo before? Yeah. Yes. Yep. Yeah. So class is just about over. Feel free to stay as long as you want. You can work on the lab, you can mess around with Google Earth, or go to your next class. I will be here Thursday, and we will solely focus on the lab. Any questions before we go? Okay. keep thinking of those GIS questions and try to stump me. All right, yes, stop recording.